Hi everyone, hopefully you're fine. And today we are going to be looking at these concepts. We are going to basically add more on our AI project, which is written digital recognition. And I'll be using the NIST dataset as I've discussed in the previous videos. So this is a supplement on what I've already discussed. So the problem that we're going to be, discussing today and what we're going to be investigating in this project is basically the same what I've been looking at. It's digital recognition, and we want to come up with a system that detects handwritten digits from scanned images of maybe text messages, papers, from photographs, from any source, as long as it is handwritten. So we want to solve the problem of people have bad handwriting. People really wish to transform whatever they have written on paper or on any document. They want to transform it into a digital form. So instead of repeating themselves to, rewrite whatever they have already written in handwriting, you might wish to just scan and you come up uh, with a digital form of all the digits you had already written. So this is what you're going to solve. And we shall be using the NIST data set, to train and verify our model if it's actually doing the right, is predicting digits. So the keywords that I'll be using here in this document that I'm, presenting, there will be handwritten digit recognition and digit segmentation and digit classification, machine learning methods, and all the rest as you see them as they're listed here. Yeah. So the scope of this project is to make character matching method realistic, to identify handwritten digits provided in our data set for the hand digit images of 0 to 9. So we want to make the scope of this project is to basically make a prediction of whatever digits you want to scan. You make a prediction and return from all the digits that are in the data set that we shall have used to train our model. So the scope of this project is to only um, detect characters, as though we want to make it so close to how a person could perform, reading digits from maybe a given paper, and we want to make it so realistic and so automated, so that we really appreciate the art of AI. So the background of this project, this problem has been on and on since the early 1980s, and it has been evolving through ages from back then. And as AI has been coming on to develop, it has also been growing, and it has been applied in many sectors, and they are applied in handwritten recognition systems are applied in bank check, in processing bank check rates, in posting zip codes, and more applications where we need to extract data from a document. So factor recognition it has been appreciated ever since, and that it has been growing ever since back then. So, however, we have some challenges with this. There are still more challenges in this kind of system. Remember, different people write in different sizes, thicknesses, in different styles. People write in different, people twist their digits. People write in little awkward ways and different ways. So our system is still finding hard time to, come up with to be 100% accurate in predicting these digits. So you might have a 3 predicted as an 8 because someone wrote it very closely, so tightly, and the system can't tell really which digit is it. But still, whatever prediction will come out, it will be from the data set. If it's maybe a mistaken prediction, if it says it's a 1 and it's predicted as a 7, 7 still is in our data set and it's what you've trained out. So even if there's a misinterpretation of the digits or characters given to the system, the return values will still be part of the data that we had used to train our model. So, and basically, this draws me to we don't have outliers in our data set. So we don't expect to have data that is outside the scope that we need. The data, all what we need is in the data set. We only need those digits 0 to 9, and our model does the prediction. So the significance of this project is, I've mentioned earlier, we have the project has it's really helpful. It's really helpful in such a way that we are going to need to extract. We might need to extract important information from our documents and all sources that we might have, and we may not want to repeat ourselves to rewrite whatever we already have. We just want to scan and automate this task so that things are ready. We don't have to do it manually to rewrite manually. You just need to scan and we come up with a proper digital form of our data. So this project will help us with that, and this will actually improve the way humans, that it will just soften people's lives. People find attempts to read other people's handwritings because of their poor writing. This will be really a general and a general for perceiving handwritten digits, and it will be really so helpful in many sectors, in banks, in post offices, and in a lot of offices, such as, people deal with money, people deal with figures, to really so help them receipts, to scan all the documents and just extract out the information that you need that is in digit form and then transfer it into digital form. To be so helpful. The data set, I've said we're going to be using the MNIST data set, and it's made of 70,000 images, each in black and white, and 60,000 of them are training images, and 10,000 of them are testing images. Each image is of size 28 by 28 pixels, and each pixel is encoded as an integer from 0 to 255. So the one means the black, it's totally black, and 255 is totally white. So it ranges from 1 to 25, 255. And therefore, our digits in these images are actually centered, and the ratio of the image is also kept. So it really gives a good this data set really gives us a big number of images that we shall use to train our model, and it helps us to help our system to learn and know what to predict. Our hypothesis, the main goal of my project is to develop an automatic handwritten digit recognition method by recognition of, connected digit strings. You might have a string of digits like maybe money, someone has written his telephone number, you want to scan it, or someone has written down a zip code, you want to scan that number. So the system is meant to do that. That's one of the hypotheses, and we have to accomplish this task by segmenting these individual digits from these images, and then we classify them accordingly, and that would make a prediction. And the algorithms that I'll be using the CNN, and by all means, it's the best algorithm to in the recognition, in the pattern recognition. It's the best algorithm to use and apply. And I'll be using the MNIST data set as I've mentioned. And for this data set, we don't have any outliers. We only need digits, and that's what story is there. We only have digits there. Yeah, handwritten digits from many writers, and that will be good for training. My objective is to use machine learning methods such as classification algorithms to train a model, identify digits around the environment. And we need to make decisions based on the given data that is in our data set. So we can't make predictions of numbers that are outside the data set, say any other number, maybe in some other language which is not English, or the real numbers that we know. So I'll be using numbers from 0 to 9 to make predictions. I have to, and my other objective is to improve the editing of written digits. So, you're going to, instead of, when you're editing your documents, instead of just manually rewriting stuff, you just go to, scan, and everything comes up in dictaform, and you're good to go. It saves you time. We also intend to, separate important data from images, as I've mentioned. Our methodology here really isn't so complicated. It's very understood. It's so interpretable. Everyone can understand what's going on with this model. So it's based on the user inputting an image. We process this image, and then we segment. If we have maybe a string of digits, maybe say we have 1999, we have a string of digits. We have to first segment it into 1999, so that so that this one image is segmented into a singular image, so that we make a prediction based on each of them. So we segment this string of digits into a singular digit image, so that we can make a good prediction. And after segmenting and extracting the features of the image, we classify them. If it's a 1, we classify it as a 1. If it's a 9, we classify it as a 9. If it's an 8, we classify it as an 8. And then we make a prediction, and we give the output of the system. And basically, this is how our model will look like. These are the steps. First, insert the image, we process it. We come up with a pre-processed image. We feed it into the segmentation part, segments it. Then we classify each small image, and then we make a prediction, and basically we give an output of our prediction, and hence the output. Hence we have ended the prediction of the image that we have already fed into the system. Here are some of the links that I've used to come up with this document that I'm using to make this presentation, and a special thanks to the authors of these documents. And some are videos, but I wasn't able to include every link that I used. And these are part of what I used. Thank you for listening.